Hi, this video is on solving one-step linear inequalities. So we're going to discuss, there are four operations that we're going to talk about, and I'll explain to you what the difference is. So when you do addition and subtraction, you're pretty much going to handle it the same way as you handle that with equations. So we have x plus 1 greater than negative 1. So what we do is we subtract 1 because we want to leave x by itself, and we subtract 1 here. This will give us x by itself on the left, and on the right hand side we get negative 2. So x is greater than negative 2. Here's negative 2. This sign indicates it's going to be open, and all the numbers that are greater than negative 2 are on the right hand side of it. Next problem, x plus 2 is less than or equal to 2, so you take away 2 on both sides. So we treat it the same way as we treat equations. X is going to be less than or equal to 0. So we're going to put a closed circle this time, because this one means closed. Closed circle at 0, and all the numbers that are less than 0 are on the left of that, so we're going to shade that. Alright, moving on. The next example, couple more like that. So x plus 2, is less than negative 3. So we take away 2, take away 2. That is going to give us x is less than negative 5. Open. Negative 5 is right there. All the numbers that are less than negative 5 are located on the left of negative 5. There's our graph. There's something interesting with example 4, but let's solve it first because we want to leave x by itself. So we have x minus 1, so we're going to do plus 1 plus 1. That is going to give us 1 is greater than or equal to x. There's a fairly common mistake that sometimes students make with this inequality, because they see the sign, because they often, if you see what we did so far, like this sign points to the left and we shade to the left, and they sometimes see this sign and they think the sign points to the right, so you're going to have to shade to the right, but that's not correct. Typically we want x to be on the left. When you did equations, it was not required, because an equality is an equality, but this is an inequality, so you can flip the whole thing, and flipping the whole thing will require you to flip the sign as well. Because think about this, if 1 is greater than or equal to x, then x itself is going to be less than or equal to 1, correct? So then after you do this, then you can proceed. Here's 1. You're going to shade it. This one's going to be closed. And then all the numbers that are less than or equal to 1 are going to be on the left of that. And there's that. But now we're going to talk about division and multiplication. So when you think about this first, if you take 10, 10 is greater than 4, I don't think anybody doubts that this is a true statement. This is true, right? 10 is greater than 4. If I multiply both sides by 3, I'm going to get 30 is greater than 12, which is true. So if you multiply by a positive number, your inequality will remain intact. What if I decide to multiply both sides by a negative number? So negative 3 times 10 greater than negative 3 times 4. So what's going to happen now? We're going to have negative 30 is greater than negative 12, and I think we have a problem because this is actually a false statement. Negative 30 indeed is less than negative 12. So what happens here when you multiply an inequality or divide also an inequality on both sides by a negative number, you must reverse the sign. Very important conclusion, because the only way you can make this statement true is by flipping the inequality sign, or reversing the inequality sign. Okay? Because now it's true. This is good. This is false. Okay, so every time when you're going to divide or multiply both sides of an inequality by a negative number, only by a negative number, you will reverse the inequality sign. And let's take a look at some examples. So here's an inequality. We'll start with something basic. 2x is greater than negative 6. We are going to need to divide by 2. 2 is a positive number, right? So there is no issue here. And we don't flip the sign. So this is going to give us x is greater than, this is going to give us negative 3. So the boundary point is negative 3. And all the numbers that are greater than negative 3 are on the right of that. By the way, one thing that I want to point out, yes, we have a negative number here, but we're not dividing by a negative number. We're dividing by a positive number. We're dividing by positive 2. Let's take a look at example 6. So here we're going to have to divide by negative 3, and I want you to be careful here. Negative 3. So since we're dividing by a negative number, we will need to flip the sign. Okay, so it's going to be x is greater than or equal to negative 3. Negative 3 here, closed. And all the numbers that are greater than negative 3 are located on the right of it, right? Okay. Moving on. A couple more. Negative x over 2 is greater than 1. So we're going to have to multiply both sides by negative 2 because right here you have negative. So we're going to multiply both sides by negative 2. This will cancel that, but because this number is negative, we are going to flip the sign. Okay, so we're going to have x is less than negative 2. Negative 2 is here, open, because it's just less than. All the numbers that are less than negative 2 are on the left. X over 3 is less than negative 1. Positive here. We're multiplying by positive 3 to eliminate the 3. So with a positive number, there is no sign flip. So we're going to get x is still less than or equal to negative 3. It's negative 3. Closed. And shade on the left. Good. I do have a couple of real-life examples just to make some real-life connection here to help understand inequalities. In real life, inequalities are actually, maybe you don't realize that, but they're more common than equations. Jane has $50 to spend on going to the movies and buying a new game. If she spent $19 last night in the movie theater, how much can she spend on the game? Well, so what do we know? How much money? Let's call it X. She already spent $19 and we want this to be less than or equal to 50. Why less than or equal to? Well, because she can't go above $50. She can spend 50, she can spend less than 50, right? She doesn't have to spend it all. Maybe she wants to save some money for later, so if she can get a game and with the movie theater it's not going to cost her $50, I'm sure she's going to be happy, right? So we solve this, minus 19, minus 19, so x is going to be less than or equal to 31. So she can spend as much as $31, right? But she cannot spend more than that. Example 10. Last month, Miguel's company raised $2,000 for a charity. This month, they want to beat that. How much should they raise each week to beat the goal? Assume there are 4 weeks in the month. So they want to beat that, so they want to raise more than $2,000, right? So 2,000 divided by 4. I'm sorry, yeah. 2,000 divided by 4 is supposed to be less than our value of x, right? No, this is not correct. We want to do x divided by 4 and we want it to be greater than